All right, let's dive into this Python for network engineering deep dive. Looks like we've got Python Mastering Network to explore today, which is perfect because, honestly, my network automation game needs a serious upgrade. Managing everything manually just isn't cutting it anymore.
I hear you. These days, having those automation skills is becoming absolutely essential, wouldn't you say?
Absolutely. I'm seeing this book touches on using PEXPECT and Paramiko, which sound like they could be really useful for that. What can you tell me about them?
They're lifesavers. TechSpect is awesome for taking over those repetitive command line tasks. Imagine you're pulling information from your Cisco devices. PEXPect can automate that whole process for you.
Oh, wow. So no more typos at 2 a.m. when I'm troubleshooting a network issue. That's a win in my book.
Yeah.
But what about security? Automating stuff on sensitive network gear always makes me a bit nervous.
And rightfully so. That's where Paramiko swoops in to save the day. It handles all those secure connections over SSH, making sure everything stays locked down tight while those scripts do their thing. You get the automation goodness without compromising security.
Music to my ears. But sometimes even automating individual commands can feel a bit, limiting. Is there a way to work with the network on a more strategic level?
There is. And thankfully, this book gets into it with network APIs.
Hmm.
Instead of bombarding a device with commands one by one, APIs let you define the outcome you want, and then the network itself figures out the best way to make it happen.
Now that sounds interesting. Can you give me a real world example of how that would actually work?
Sure, let's say you're configuring VLANs across a bunch of Cisco devices. Instead of manually going through each one, you'd use their API. You basically tell the network, I need a new VLAN with these specific settings, and the API does all the heavy lifting to make it happen on every device.
That's way more efficient than my current method of copying and pasting commands. Are we talking about a completely different way of thinking about network management?
You got it. What's even cooler is that Python Mastering Network goes a step further and talks about using Flask, a Python web framework, to build your own custom APIs.
Whoa, hold on. Building my own APIs. So it's not just about using what vendors provide, but actually creating APIs tailored to my specific needs and workflows.
Exactly. Imagine having a custom API that lets you manage your entire network infrastructure, from device configs to security policies, all through an interface you design and control.
Now that's powerful stuff. But this all sounds like a lot of data to keep track of. The book also mentions something about network monitoring with Python. Does it cover how to wrangle all that information?
Absolutely. Network monitoring is so crucial, and Python can totally change the game. It covers using SNMP for gathering data, but here's the cool part. It also shows how to turn that data into something you can actually use.
So instead of staring at a wall of numbers, I could actually see trends and spot issues before they become major problems.
Exactly. It even talks about using libraries like Matplotlib and Pygel to create cool visualizations and interactive graphs from your SNMP data.
Okay, that's way better than trying to make sense of spreadsheets all day. But this is starting to feel like a lot to manage all these scripts, APIs, and now monitoring data. How do I keep it all organized?
I was just about to get to that. That's where a tool like Jenkins comes in, which thankfully the book covers in some detail. It can help you wrangle all those automation projects and bring some order to the chaos. Imagine this. Think of it like Jenkins is this super organized air traffic controller for all your network automation projects. It can schedule when things run, help you manage changes to your code, and even automatically deploy those new configurations and scripts you've written.
So instead of me manually running each and every little update, I can hand the reins over to Jenkins and let it do the heavy lifting. That almost seems a bit too hands-off. How do I make sure things don't go totally haywire?
Well, a big part of what makes Jenkins so great is that it's designed with those checks and balances in mind. The book talks about how you can have Jenkins automatically test your code as a core part of that automation process. That way you're way less likely to run into those, oops, I broke the network moments.
Okay, that definitely eases my mind a bit. It seems like Python Mastering Network really hammers home this idea that with tools like Jenkins and the power of Python, you can really take network operations to the next level.
Absolutely. It's all about breaking free from those repetitive tasks that bog us down and letting you focus on the bigger picture, things like squeezing out every ounce of performance from your network, making it as secure as Fort Knox, and ensuring it's reliable no matter what life throws at it.
Now, that's music to my ears. We've covered a lot of ground so far, from ditching those tedious CLI commands with PEXPECT and Paramiko to dipping our toes into the vast world of network APIs, and now orchestrating it all with Jenkins. What other Python-powered tools should we explore?
Since you brought up security earlier, how about we shift gears and focus on that for a bit? Let's talk about how Python can be your secret weapon for building a network that's as secure as Fort Knox.
I'm all ears. But honestly, when I think of seriously hardcore security tools, Python doesn't always spring to mind. Is it really robust enough for that kind of work?
You might be surprised. Python Mastering Network actually spends some time talking about a tool called Scapy. Have you ever used it before?
Escapee. The name rings a bell that I can't say that I have. Is it some new fancy antivirus software?
Not quite,
Yeah.
but much cooler. Imagine having a network packet construction kit right at your fingertips. You could build and tweak packets down to the tiniest detail, like being able to edit the headers, the payloads, everything. That's what Scapy lets you do.
Wait a minute. You're telling me I could create my own custom network packets from the ground up? That sounds incredibly powerful and maybe a tad dangerous in the wrong hands.
Like they say, knowledge is power. And you're right, any tool can be misused. But Scapy's real purpose is to be a force for good for security auditing, pen testing, even building those custom security tools tailored to your unique environment.
Okay, so I could like simulate a cyber attack on my network to see how well it holds up, or test if our intrusion detection system is actually earning its keep.
You absolutely could, but it goes way beyond just playing defense. Imagine being able to analyze suspicious network traffic with a fine-tooth comb, troubleshoot those weird network glitches that make you want to pull your hair out, or even design a system that sniffs out and quarantines malicious activity before it can even blink, all with Python and Scapy.
Now you're speaking my language. This sounds amazing, but I have to admit, the idea of manipulating network traffic at that level seems like it would require a deep, deep understanding of how networks work under the hood. Does Python help bridge that gap at all? Or am I looking at a crash course in networking fundamentals?
It's a bit of both, actually. What
Yeah.
makes Python so great is that it lets you work at a higher level, abstracting away a lot of the complexity you'd usually find in network programming. But at the same time, it gives you the power and the flexibility to really get down into the nitty-gritty details of how networks tick if you need to.
So it's robust enough for seasoned network pros, but still approachable for someone like me who's just starting their automation journey.
You nailed it. That versatility is a huge part of why Python's become such a rock star in the networking world. And speaking of versatile, it reminds me of another important concept that Python Mastering Network touches on: asynchronous programming. Have you had a chance to explore that much?
Asynchronous programming, huh? I've definitely come across the term before, but I always figured it was more for the software development whizzes, not so much for network folks like me.
Ah, I see we've stumbled upon a common misconception. Asynchronous programming is becoming more and more crucial for network engineers, especially as we see the rise of applications that demand real-time responsiveness. Think about it in your typical program. The code executes one task at a time. Now, if a task takes a while to finish, let's say it's waiting for a response from some far-off server, the whole program's stuck waiting.
That sounds incredibly inefficient.
It can be, especially when you're dealing with dynamic networks where things are happening all at once, all the time. Asynchronous programming is like having a whole team of chefs in the kitchen, each working on a different part of the meal simultaneously, instead of just one chef trying to do everything in sequence.
Okay, I like that analogy. So instead of my code getting stuck waiting for one task to finish, it can move on to other tasks, making way more efficient use of things.
You're getting it. It's a total game changer, especially for those tasks that involve a lot of waiting around or crunching massive amounts of data. And when we're talking about network security, that speed can make all the difference.
So theoretically, I could have a single program that's monitoring for suspicious activity, analyzing log files for any red flags, and responding to incidents all in real time without missing a beat. It sounds almost too good to be true.
You're not far off. It's like having a whole team of super efficient virtual security specialists working tirelessly behind the scenes to keep your network safe and sound. But enough about the what for now. Let's talk about the how. How do we actually do this asynchronous programming magic?
Yeah, please do tell. How do I go from a network engineer with Python skills to a master of asynchronous programming?
Well, the book, Using Asyncio in Python, would definitely be a great deep dive all on its own. But to give you the short version, Asyncio is a really powerful Python library that's built to make writing asynchronous code much easier.
Asensio, got it. Definitely adding that to my to-learn list. It seems like it's only getting longer. It's pretty incredible to see how Python can be used for so many different parts of network management. But I'm also curious about its role in another area that's becoming increasingly important for everyone, the cloud.
You're right to be thinking about that. The cloud is evolving faster than, well, something that evolves really fast, and Python's right there in the thick of it, helping to shape the future of cloud-based networks.
So we're talking about virtual networks living entirely in the cloud, firewalls that exist only in the digital realm, all that good stuff.
You got it. Your source material actually highlights Amazon Web Services, or AWS as the cool kids call it, as a prime example. It's become a major player in the cloud arena, offering up a whole smorgasbord of networking services. And here's the kicker. You can manage and automate a lot of those AWS services using drumroll, please Python.
No way. So I can finally ditch the AWS console with its million menus and submenus and just write some nice clean Python code to manage my whole cloud infrastructure.
Exactly. Even for seasoned pros, navigating the AWS console can sometimes feel like you're lost in a labyrinth. But with Python and a library called Boto 3, which is built specifically for talking to AWS, managing your cloud resources can actually become almost, dare I say, enjoyable.
Boto 3, you say? Sounds intriguing. Okay, give me a real-world example. Let's say I need to whip up a new virtual private cloud in AWS. Could I really do that with just a few lines of Python?
Absolutely. You could have a fully functional virtual private cloud up and running faster than you can say cloud networking, all thanks to Python and Boto 3. And we're not just talking basic stuff here. We're talking configuring security groups, setting up load balancers. Heck, you can even deploy whole applications to the cloud using Python.
Okay, now you're just showing off. This really does feel like a whole new world of possibilities opening up. But before I get too carried away, I have to admit it's also a little overwhelming. With all this talk about automation, APIs, and now cloud platforms, it's hard to know where to even start.
I hear you. It's a lot to take in. That's where a more systematic approach can really help. And one of the absolute fundamentals of working with code, especially when you're dealing with large-scale projects, is version control. It's something Python Mastering Network emphasizes, and for good reason.
Version control. Now, that's a term I've come across before, but I'll be honest, I've always thought of it as a software developer thing, not so much a network engineer thing.
Time to ditch that outdated mindset. Think of version control as a time machine for all your precious network configurations. Any change you make, big or small, it's tracked, documented, and you can easily rewind back to any previous version if you need to.
So no more frantically digging through old backup files on my hard drive, desperately hoping I can find that one config file from 6 months ago. That sounds like a dream come true.
You've got it. With version control, you can track every single change made to your code, your configuration files, scripts, even your documentation. It's like having a super detailed audit trail for your entire network, which is incredibly valuable if you ever need to retrace your steps. Plus, it makes collaborating with other engineers on projects much smoother since everyone's always on the same page.
Okay, you've convinced me. Version control is a must-have, not just for those software gurus, but for us network folks too. But how does this magical version control system actually work? What kind of tools are we talking about here?
The gold standard for version control, the one that's used far and wide in the industry, is a tool called Git. And here's the best part. You can use Git to manage your network configurations just like you would manage lines of software code.
So instead of just saving a million different versions of my config files with cryptic names like config final v2 final.txt, I could have a central repository where every change is tracked. I can add notes and comments and even work with others on updates without creating a tangled mess.
You're catching on quickly. Imagine being able to create separate branches for different projects or features so you can experiment without the fear of blowing up your main configuration and then seamlessly merge those changes back into the main branch when you're ready.
Okay, now that's what I call working smarter, not harder. But I have to ask, is Git something I need to learn completely separately, or does our trusty friend Python come into play here as well?
Never fear, Python has you covered. There are some excellent Python libraries out there that let you interact with Git directly through your code. We're talking writing scripts to automate things like saving changes, creating branches, even merging different versions together, all without leaving your comfy Python environment.
Wait. So I can automate my version control tasks now, too. This is getting out of control. In a good way, of course.
It's all about making your life easier and getting rid of those manual tasks that are just begging for human error to creep in. And since we're talking about streamlining things, Python Mastering Network also introduces a concept that pairs perfectly with version control. Continuous integration.
Continuous integration. Okay, now that one rings a faint bell, but I can't quite put my finger on it.
Think of continuous integration as version control on steroids. It takes all that good stuff we just talked about and cranks it up to 11.
All right, You've piqued my interest. Give me the rundown. What is this continuous integration sorcery all about?
Picture this. You've just made a change to your network's configuration. Maybe you're tweaking a firewall rule or adding a shiny new VLAN to the mix. With Continuous Integration CI for short, that change can be automatically tested for any hiccups, validated to make sure it's playing nicely with everything else, and even deployed to your network devices without you having to lift a finger.
Hold on. So you're saying I could potentially roll out config changes across my entire network with just a few keystrokes. That sounds incredibly efficient, but also kind of terrifying. What happens if something goes wrong?
That's the beauty of continuous integration. It's not just about automating deployments for the sake of it, it's about weaving in a safety net every step of the way. You see, with Cyzia, you usually set up a bunch of automated tests that run like clockwork every time you make a change. These tests are like your vigilant watchdogs, sniffing out errors and making sure those changes aren't going to wreak havoc before they ever get close to your precious network.
So it's kind of like having a dedicated QA team, tirelessly testing and validating every single change I make, giving me that extra peace of mind that things are good to go.
You got it. Continuous integration takes a massive weight off your shoulders and lets you focus on what you do best, designing, building, and optimizing those networks like the rock star you are. But let's not get ahead of ourselves. Before we even think about automating deployments, we need to be absolutely sure that those network configurations are rock solid.
You make a good point. There's no sense in automating bad configurations. That's just asking for trouble.
Exactly. And that's why the next essential ingredient in our network automation recipe is testing. I know, testing might not be the most glamorous word in the tech world, but trust me, it's the unsung hero of any well-oiled network. It's easy to get laser focused on all the cool tools and fancy automation techniques, but at the end of the day, none of that matters if we don't have a rock-solid way to keep our finger on the pulse of our network. We need to talk about network monitoring.
Yes, network monitoring, the unsung hero of any well-managed network. But I have to say, it can also be one of those necessary evils. Endlessly sifting through log files and trying to make sense of those cryptic performance graphs. It can feel like a never-ending battle.
I feel your pain. But on the bright side, Python can be a total game changer in this area. Python Mastering Network is packed with examples of how you can use it to go beyond just collecting data. It shows you how to make that data work for you.
You're telling me I can finally escape the soul-crushing monotony of spreadsheets and command line tools? Tell me more. I'm ready to be amazed.
Well, let's start with an old friend, SNMP. It's been around since, well, forever, and for good reason. It's a tried and true protocol that's the workhorse of collecting valuable data from all your network devices.
Right, SNMP. Good old SNMP, reliable as can be, but not exactly known for its user-friendliness.
And that's where Python comes riding in to save the day. Instead of wrestling with those clunky old command line tools or trying to decipher raw SNMP data, you can use slick Python libraries like PySNMP. They make collecting, processing, and even visualizing that data, actually,
I see.
enjoyable.
So instead of being bombarded by a wall of meaningless numbers, I could have a sleek dashboard that shows me exactly how my network's performing in real time.
Precisely. Imagine it. Custom dashboards that display everything from bandwidth usage and CPU load on your routers and switches to the health of those mission-critical network services. And the best part, since you're working with Python, you've got the flexibility to make those dashboards as simple or as fancy as you like.
Okay, now you're speaking my language. That's a serious upgrade from my current method of logging into each device manually and pecking away at the command line. But we both know SNMP is only one piece of the puzzle, right?
You're absolutely right. And this book doesn't disappoint. It also covers other monitoring heavy hitters, like SFlow and NetFlow. We're talking about tools that give you a much, much deeper understanding of how traffic is flowing through your network. Think of it like this.
Oh, I love a good analogy. Lay it on me.
Imagine you're a detective solving a complex case. SNMP is like getting eyewitness accounts. They give you a basic idea of what happened, but there are gaps in the story. Now, SFlow and NetFlow, those are like getting your hands on the security camera footage. They show you exactly what went down in crystal clear detail.
So I could see which applications are hogging all the bandwidth, which devices are chatting with each other, and even trace the route of a single packet as it zips through my network.
You've got it. That level of visibility is pure gold when you need to identify bottlenecks, squash those annoying performance issues before users even notice, or even catch malicious activity before it can wreak havoc.
This is blowing my mind. I'm starting to see the bigger picture here, but I have to ask, all this data analysis and visualization and real-time monitoring magic, it seems like it would require a massive investment in expensive tools and infrastructure. Am I right?
You might be surprised. With Python and a bit of that network engineer ingenuity, you can achieve a lot without breaking the bank.
Yeah.
There's a ton of amazing open source tools out there like NTOP and Elasticsearch that you can easily integrate with your Python scripts to create really powerful and cost-effective monitoring solutions.
Okay, those names definitely ring a bell, but give me a quick refresher on what they're all about.
Think of NTOP as the air traffic control tower for all your network traffic. It gives you this real-time bird's eye view of everything that's happening, which devices are talking, which applications are gobbling up bandwidth, even where your users are located geographically. And the coolest part, it's got this nifty Python API, so you can add your own custom features and integrate it seamlessly into your existing monitoring setup.
So not only can I see what's happening, but I can actually automate tasks based on that information too. Now we're talking.
And then there's Elasticsearch. If NTOP is your air traffic control, then Elasticsearch is your giant network data warehouse. It lets you take huge amounts of network data. We're talking log files, NetFlow records, performance metrics, whatever you can throw at it, and it lets you index it, search it, and analyze it all in real time. Plus, it has this crazy powerful query language that lets you unearth those hidden patterns and insights that would have stayed buried otherwise.
So let's say I suspect there's been some shady activity on my network. Could I use Elasticsearch to scan all my network devices' logs for specific events and finally track down the culprit?
You absolutely could. Or let's say you've been dealing with those annoying intermittent performance issues that seem to vanish as quickly as they appear. Elasticsearch to the rescue again. You could use it to combine data from all sorts of sources, their routers, switches, servers, and actually pinpoint the root cause of the problem. Way faster than you could with those traditional monitoring tools.
This is amazing. It really feels like the only limit is my imagination. Python, combined with these open source tools, seems like a recipe for network monitoring greatness.
Now you're getting it.
Yeah.
Python isn't just about taking those tedious tasks off your plate. It's about giving you the building blocks to craft a network that's not just automated, but truly intelligent, adaptable to whatever gets thrown at it, and ready to face whatever the future holds.
I'm totally on board. But I have to be honest, it's also a little intimidating. There's so much to learn and put into practice. What advice would you give to someone who's just starting on their Python for networking adventure? What helped you the most when you were getting started?
You know, it's funny, when I first started out, I wish I'd embraced the learning process a bit more. Don't be afraid to jump in, get your hands dirty, and experiment. Python's known for being a beginner-friendly language, and there are tons of resources out there, from online tutorials to fantastic books like Python Mastering Network that we've been exploring today. And of course, there's a huge community of network automation enthusiasts who are always happy to help a fellow coder out.
It's all about the journey, right?
Exactly. And remember, you don't have to boil the ocean all at once. Start small, maybe tackle automating one tiny task that's been bugging you, or write a simple script to gather some basic data from your network. As you get more experience and confidence, you can gradually level up those automation skills and conquer those bigger, more challenging projects.
That's great advice. This has been an incredible deep dive. I feel like my Python for networking toolbox has gotten a serious upgrade today. A huge thank you to you, our expert, for sharing your wisdom and insights with us.
The pleasure was all mine. And remember, everyone, the future of networking is being written in Python. Why not grab your keyboard and join the revolution?
I'm ready to trade in my command line crutches for the sleek, streamlined power of Python. To all our listeners out there, we hope this episode has sparked your curiosity and maybe even inspired you to explore the incredible possibilities of Python for networking. Until next time, keep learning, keep automating, and keep building the networks of the future.